Hello kids, Shubhamangalam Athletical Scholar, myself Sukhdeep. I'll be taking up class 9 physics for today, and we will continue with chapter 2 motion, and we are on page number 23 class. So we have discussed about acceleration before this, and the formula for acceleration is change in velocity per time. So what does this mean? What is the definition of acceleration? It is the rate of change in velocity. At a particular instant, if you are changing the velocity, whether you're moving forward or whether you're going backward, that is what is called as acceleration. The opposite of acceleration, where acceleration basically means moving in a forward direction at a changed velocity. What could be the acceleration when you're going in the reverse direction? That is called as deceleration or retardation. Basically, we have discussed about this. Also, we also went through too many figures. One was this figure number 15, the motion diagram. You need to understand at which point the speed is going to be the highest, and we came to a conclusion that at point B the speed is going to be highest because at that point the bus driver is going to take a very sharp curve. Do you understand? So here, before this, we have discussed about uniform and non-uniform motion, and we have also dealt with how to draw graphs of it. We have discussed what can affect the motion of an object. If the velocity is changing, then it is called non-uniform motion, and if the velocity is not changing, then it is called uniform motion. The uniform motion graph is always going to be a straight line from the origin. Also, we have discussed different cases where the velocity changes but the direction of motion does not change, and we have discussed a circular vector case over here where the direction of the motion is changing but the velocity remains constant. Do you understand? So yes, we have gone through a lot in this chapter. Now we need to go through the equations of uniform accelerated motion. So class, we will discuss a few important equations of uniform accelerated motion over here. What do you mean by uniform accelerated motion? When a body is moving with a steady velocity. Do you understand? And there is a possibility that it might change its acceleration because of the rate of change in velocity. Do you understand? And when the velocity changes, it is non-uniform motion. So there are very simple equations over here, and these equations will be used in the problems. So you need to understand the equations and why are we using these equations in the problems further. So for now, let's discuss them together. So equations of uniform accelerated motion. Consider the motion of an object along a straight line with constant acceleration. So what is uniform acceleration? When the rate of change of velocity is constant. Do you understand? When the rate of change of velocity is constant. In what cases is it going to be constant? If I consider this to be a distance versus time graph, the uniform motion graph is going to look something like this, a straight line from the origin. This means, for example, if I wanted to plot as per the table, it would be, let's take this as time and let's take this as distance. And if we plot this in the 0th second, 0 distance, 0 kilometers. In the second it is 2 meters. In the third second, it is 4 meters. In the fourth second, it is 6 meters. Can you see a certain consistency over here? This means the object was moving with constant acceleration. Okay, when the body moves with constant acceleration, it is said to be in uniform acceleration. Okay, one word or the other. So acceleration, the formula is acceleration is equal to change in velocity by time taken. Do you understand? It is the rate of change of velocity. Do you understand how much the velocity has changed in a particular unit time? That is what is called as acceleration. Okay, so now, for example, if you and I were in a car and I was driving and we stop at a signal, and as soon as the signal shows green, I accelerate the car and I take it forward. Do you understand? At that particular time unit, how much was the change in the velocity of the car? That would be called as acceleration. It is not always going in speed or decreasing your speed. It is also that. It is one of those factors. But mainly it is how much velocity has changed in a particular instant of time. Okay, so now acceleration is equal to change in velocity by change in time. This can also be written as delta V by delta T. Okay, delta V is nothing but V minus U. and change in time will be further, will be like, change in per unit time. That is nothing but delta t also can be written as t2 minus t1, the final time minus the initial time. We will learn this further. So here, let's read this. So the delta here denotes changes. That is what I told you. Delta v by delta t. Let's discuss this again. Acceleration is equal to change in velocity by time. To show the change in velocity, how do you denote velocity? You denote velocity as v. How do you denote the time as, let's write this as time taken. Okay, the time taken means the start time and the final time, or both need to be considered. Do you understand? Definitely the final time is going to be greater than the start time. Okay, that is why change can be represented as a delta over here and velocity as v. So delta v represents the change in velocity. What is change in velocity? The final velocity minus the initial velocity. What do you mean by final velocity? The velocity that was finally in that particular object when that object has completed a certain motion. Do you understand? Or reached the destination. What is initial velocity? The start velocity. Okay, and delta t is nothing but the change in time. Okay, at t1 the body started moving with an initial velocity u. At t2 the body had undergone the final velocity v and reached the destination. It is like this. Okay, so now like u be the velocity at the time t is equal to 0. So the initial time delta t can be written as t2 minus t1. T1 is considered as 0 over here. Can you see the first entry that we always give in a table? It is at the 0th second, the body traveled 0 meters or 0 kilometers. That is why the t1 value will be taken as 0. Do you understand? So here, and v be the velocity at the time t, and let s be the displacement covered by the body during time t as shown in the figure. Fine. There is an object over here that is at t is equal to 0. That is the first second. At t is equal to 0 seconds, it is moving with an initial velocity u, and at t is equal to t seconds. Okay, this is the final time. At t is equal to t seconds, okay, it has the velocity of this particular body becomes v, which is nothing but the final velocity. Let me repeat this. This is the object. Okay, this is the object and it is moving with an initial velocity u at the starting point, and at the starting point the time is considered as 0 seconds. Okay, that is the t1 part. Do you understand? And once the body has started moving, the velocity is considered to be v, which is nothing but the final velocity, and at time t seconds it has reached a particular place. Okay, read that statement again over there. Let u be the velocity at time t is equal to 0. Do you understand? At time t is equal to 0, the velocity of the object is u. What is u? It is the initial velocity, the start velocity. Let's continue. And v be the velocity at time t. So after traveling for a certain amount of time, which is nothing but t seconds, the velocity of the body has become v now. And that is the final velocity. So the velocity got changed from initial velocity to final velocity in t seconds. Did you understand? And it has covered a certain distance s. Okay, everybody's clear with this? The object has moved from point 1 to point 2 and it has covered a certain distance which is represented by s. Okay, so and v be the velocity at time t and let s be the displacement covered by the body during time t. Did you understand this? So what do we have in our question over here? We have initial velocity, that is the start velocity of the body, the velocity at which the body started moving. The final velocity, the body with which the velocity with which the body was moving and reaching the destination. Do you understand? And t is equal to 0 seconds is the start time, and t is equal to t seconds is the time taken by the body to reach the point B or reach the destination, and the distance or the displacement between the 2 points is considered as s. Did you understand now? So here we are going to write further things. Okay, so we are going to write a very simple equation over here. As we have seen, acceleration is equal to change in velocity by time. So acceleration can be denoted as a. small a and is equal to, change in velocity can be written as v minus u and time taken can be written as t. Do you understand? Earlier I wrote it as delta t. Yes or no? What do you mean by delta t? Change in time. Change in what time? Change in the final time minus the initial time. T2 minus T1. The initial time is always going to be 0. So T2 minus 0 is nothing but T2. In our case, T2 is written as T seconds. Did you understand? That is why we write there change in velocity by time taken as v minus u by t. Do you understand this? Change in velocity is written as final velocity minus initial velocity by the time taken. Now we can alter this equation a little bit. I can multiply t to a. So it is going to become at and u is taken this side. So this becomes plus u is equal to v. So what is the new equation now? V is equal to u plus at. This is your equation number 1. Everybody clear with this one? So this is how we got the equation number 1. Let's see further what all do we get. Okay, now the next part of the equations. You know how to find out the average of two numbers. How is it? The sum of the numbers by the number of numbers. Yes or no? If there are two numbers, 1 and 2, and I want to find the average in them, what do I do? The sum of the numbers. How many numbers are there? By the number of numbers. 2 plus 3, 3 by 2. That is going to be the average, 1 point something. Yes or no? 1.5 approximately. That is how you find out the average of two numbers, because nothing but the sum of the numbers by the number of numbers. Okay, so when I want to find out average velocity, it is going to be v plus u by 2. Yes or no? There are only two velocities. What are they? Final velocity and initial velocity. I want to find out what is the average velocity. So I'm going to sum up both the velocities. And how many velocities are there? 2. So that is why the sum of the velocities by 2. Do you understand? That is how you write average velocity. Okay, now average velocity has one another formula that we have studied. Average velocity is equal to displacement by time. Displacement is given as s in our question and the time will be given as t. Did you understand? On page number 22, no, on page number, let me see, it was done way ago. On page number 16, we have the formula average velocity is equal to displacement by time taken. I will write it over here, page number 16, so that you refer it and you don't get confused from where did teacher get displacement by time. So yes, we have a formula average velocity is equal to displacement by time. Do you understand? We know that the left hand side of both these equations are the same. So we can write s by t is equal to v plus u by 2. Yes or no? Done? Everybody clear with this? Okay. I wrote two equations of average velocity. I know that the average sum of two numbers will be nothing but or the average of two numbers is going to be the sum of the numbers by the number of numbers. The same way, if I want to find out the average velocity, it is going to be the sum of the velocities by 2, because there are only two velocities. It is the final and the initial velocity. Similarly, we also have another formula for average velocity. It is displacement by time taken. So I know the LHS of these two equations is the same. So we can also equate the RHS. So S by T, which is displacement by time, is equal to V plus U by 2. Okay, now we have a value here for V. Can you see this? Okay, V is equal to U plus AT. Did you see that, class? So we can substitute equation number 1 into equation number 2 over here. If I write this as equation number 2, in place of V, I can write U plus AT. Did you understand? So S by T is equal to U plus AT plus U by 2. Everybody clear till here? So next, S by T is equal to U plus U is nothing but 2U plus AT by 2 again. Everybody clear till here? Next, we need to see at this left hand portion over here. So here, taking this equation this side, S by T is equal to, look at this. The denominator is for both the numerators, yes or no? So 2U by 2 plus at by 2. Okay with everybody? So here what am I going to do? This 2 and this 2 can get cancelled. Did you understand? So s by t is equal to u plus, this is nothing but 1 by 2 into at. Okay, in the numerator it is actually 1. Did you understand? Because at by 2. Okay, at by 2 is nothing but 80 into half. Okay, 1 into 80 is what? 80. We get the same equation back again. Did you understand? So instead of writing 80 by 2, I wrote it as 1 into 80 by 2. 1 into 80 is again going to be 80 over here. So I'm just modifying it a little bit. I'm writing the same thing but in a different way. So there is no number over here. This means the number here that I can write is 1, because 1 into anything will be the number again. Did you understand? 1 into anything is going to be the variable again. So 1 into 80 is again going to be 80. So this does not make any difference. But it is going to make a difference when I write the equation further. Did you understand? So S is equal to U. I'm going to multiply T with this entire equation over here. It is going to be UT plus half. 80 into 80 is nothing but 80 square. So this is my equation that I need to understand. Fine. Okay. Now further. So that was our first equation, V is equal to U plus AT. Did you understand this? I can modify this equation further. I can take U this side and becomes V minus U is equal to AT. I can take A in the denominator and I can write it as V minus U by T is equal to A. Okay. Now this can be my equation number 4. So now further I need to consider one more notion over here. I need to substitute T in equation number 2. And what was my equation number 2? It was V plus U by T by 2 is equal to S by T. You remember average velocity? Average velocity can be written as V plus U by T is equal to displacement by time taken. Did you understand? So in place of T, okay, let's write A over here and let's take T over here, because we wanted T in the, we wanted to substitute T over here. I'll recollect it again. V is equal to U plus AT class. This was my first equation. I modified the equation by taking U on this side. It becomes V minus U. Then I take A in the denominator and I get a replacement or a substitution for T in my this equation. So T can be written as V minus U by A. Did you understand this? So if I want to multiply T to this, it is going to be V plus U by 2 into T is equal to S by nothing, because T is already taken this side. And this was my equation 2. Remember? So I am just going to substitute the value of T in my equation number 2. So what do I get? I get V plus U by 2 into V. What do I get? V minus V plus U by 2, and here I have V minus U by A is equal to S. So you must have learned in maths like A plus B into A minus B is equal to A square minus B square. Similarly, if you see V plus U into V minus U, it is going to be what? It is going to be V square minus U square. So V plus U into V minus U is going to be written as V square minus U square. Multiply the denominator also, it becomes 2A, and on this side you have S. Okay, take 2A this side. V square minus U square is equal to 2AS. This is my equation number 5. Okay, this is what is given on page number 23 and 24. Okay, so the equations that you need to remember is V is equal to U plus AT, S is equal to UT plus half AT square, and V square minus U square is equal to 2AS. I showed you how the derivation happened. It was pretty simple. Okay, it is not at all complicated. You firstly need to understand what is the first equation, and thereafter you are easily able to do it. Try to practice it at least 3 times, you get it. Did you understand? So the Sakshi for today is going to be that you are going to practice this particular equation 3 times. Okay, and from page number 23, from equations of uniform accelerated motion onwards till here, till we get this last equation, V square minus U square is equal to 2AS, you are going to practice this particular these particular equations at least thrice. Okay, Try to do it in one go. First time, look at it, look at each and every equation, and then try writing it. Second time, you still don't understand, again write it. Third time, try writing it without seeing. You definitely will be able to get it. Okay, it's pretty simple. Okay, before I end the class, let me discuss the convention rules over here. The note: if the speed of an object increases, the direction of the velocity and acceleration are one and the same. Okay, if the speed of the object is increasing, this means that the object is going in the direction of motion and it is accelerating. Okay, so both mean the same over here. So it is going forward, so acceleration is also increasing, it is rating forward. Now the second point: if the speed of an object decreases, this means if it is going in the reverse direction or if it has stopped by applying brakes, the direction of velocity and acceleration are in opposite directions. Did you understand? This means the body is undergoing deceleration and is going in the reverse direction. In such a case, at a certain instant, the speed becomes zero. For example, if I apply brakes to my car, okay, it is going to stop. Acceleration is nothing but in the reverse direction over here, which is deceleration, and it is going to be negative, and it is going to be opposite to that of the direction of velocity. The direction of velocity was actually forward, but I applied brakes. That is why my car started moving backwards and took a brake. At a certain instant, the speed of my car is going to be zero. So it went against the velocity over here. So that is why it is called as deceleration, because it is going in the reverse direction. If there exists an acceleration of a body at a point where its speed becomes zero for an instant, at what instant can the acceleration of the body become zero? Either it is going to be at rest or it has been brought to rest by applying brakes. Okay, then the body returns in the direction of acceleration and moves continuously, like in the case of a stone thrown vertically up into the air. For example, if I'm going to take this pen and throw vertically up into the air, similarly, if I take a stone and throw vertically up into the air, the stone has to fall down. This means it is going against the direction of velocity. The direction of velocity should actually be upward, but the stone is actually falling down. This means it is undergoing deceleration. And why is it undergoing deceleration? Because of the gravity. Did you understand? And at certain instant, it is going to fall down, and the velocity is going to be zero. Okay, so it is going to return in the direction of acceleration and move continuously. Do you understand? So once you throw the stone upwards, it has definitely undergone a change in acceleration, but after some time or after some seconds, it is going to come back in the direction of acceleration and fall down. Do you understand? It is going to come back in the reverse direction and again fall down. Let's see the sign conventions. These rules help to signify the direction of displacement, velocity, and acceleration. Okay, can you see the first picture over here? The O is nothing but the origin. Okay, anything that is moving on the right hand side of the origin, then the displacement of that particular body is considered to be positive. Definitely, the opposite of this is going to be negative displacement. And what is the opposite of this? When the body is moving on the left hand side. Okay, when the body is placed on the left hand side of the origin. For example, I consider the stone in my hand over here, and at a certain point, if I consider the origin, and if I throw up the stone, fine, let's consider this particular point to be the origin, and I throw the stone and the stone moves upward. This means it was undergoing a positive displacement because it was going up. Did you understand? But the stone started falling down, and it went down and fell down on the ground and not on my hand because it was down. Okay, it missed my hand and it fell down. This means it has undergone negative displacement because it has completely fallen down. Did you understand? The same aspect over here, the longitudinal aspect that I showed you or told you right now of throwing the stone up and the stone falling down because of gravity, that same idea you need to apply in horizontal motion also. You can see a straight line over here with an origin. Something that is going on this particular hand side will undergo positive displacement, and something that is placed on this particular, the left hand side, is going to undergo negative displacement, the opposite of what actually happened initially. The body is not moving. If I hold my hand like this, is the body undergoing positive displacement or negative displacement? No, it is at rest. Okay, so displacement is going to be what? Displacement of a body at rest is going to be zero. Did you understand? Similarly, let's see the right hand side over here. Okay, let's see how does the velocity change. So the velocity, you can see the person running in a certain direction. You speed up your car and you just move from your house to the straight lane and you keep moving. You don't take a reverse at all. This means your body is, the car is undergoing a forward acceleration. You take a break. This means the body has undergone a deceleration or the reverse acceleration. Did you understand? So the velocity is positive when you're going in the forward direction, and when you're going in the reverse direction, the velocity is going to be negative. Did you understand? Similarly, whether you are at this particular point of the origin or whether you are at the other side of the origin. Did you understand? Look at the diagrams carefully, you will understand. The person is moving, is running forward. Okay, it is at the right hand side of the origin and it is moving forward, and at the same point it then turned and came back towards the origin. So in that particular side itself, it has undergone both positive velocity and negative velocity because it changed its direction of motion. So velocity depends on the direction of motion, it does not depend on the position of the object. Okay, the displacement is going to depend on the position of the object. Okay, so now, for example, look at the next two lines. Look at the boy over here. The boy is on the left hand side of the origin, but he is moving towards the origin. He is moving towards the origin. This means he's undergoing a positive velocity. If he is going away from the origin, this means he's undergoing negative velocity. So doesn't matter whether the boy was placed on the LHS of the origin or the RHS of the origin. No, it all depends on the direction of his motion, whether he's moving forward or backward. Did you understand? So you will understand this better once we are, taking up the problems, and if we have any relevant problems of this. Basically, you need to understand the stone and the freely falling body. If it is not undergoing any displacement, displacement is zero. If it is thrown upwards, then it is positive displacement. You leave it, then the stone falls down. It is undergoing negative displacement or deceleration. Okay, if this point is called as the origin and I move in this particular direction, this means I'm undergoing forward positive velocity. If I come back to the origin, this means I am undergoing negative velocity. Okay, if I am at this particular position and this is the origin and I move towards the origin, then I am undergoing positive velocity. If I go away from the origin, then I am undergoing negative velocity. Okay, that is what the person is trying to tell over here. You can look at the pictures and definitely understand what do we mean over here. Okay, once we do the problems, it becomes much more easier. So the next lab activity and few problems we will discuss in the next video. And before that, you can definitely note down Sakshi. Okay, so I guess we are done with the 2 pages of derivation as well as sign convention. Okay, it's physics Sakshi. So classwork, page number 23 and 24 done. Okay, homework, practice the derivation on page 20 and 24 thrice in your rough notes is also okay. Okay, if you have a rough notes book in your notes, I have written notes, you can choose any notes, your classwork or your rough notes. Even piece of paper is okay, but you need to maintain it and not throw it like gliders. Understood? So here, so page number 23 and 24 are done, and I want you to practice the derivation on page number 23 and 24 3 times in your notebook. Thank you for now.